Oh, hello class. We're back, and we're working on page 2, and hopefully this doesn't take as long as it did before. So we're going to work on um, the solutions for number 3 right now, where we want to put the exponents in this form where we have a constant times a raised to a power and b raised to a power, where c, p, and q are numbers. So in the first one, you would take, well, I'm just going to go through and work through it so you don't have to listen to my voice too long. 2 cubed is 8. A squared cubed is a to the 6th, and that's all over b. But they wanted it in this form where a and b were in the numerator, so I'm going to have to rewrite this as 8 a to the 6th, b to the negative 1st. The next one, a square root, is a half power. So you're going to have basically 9 to the half power, a to the half power, and b to the 3/2 power. So the only thing I really have to do to simplify this is I want to rewrite this as 3a to the 1/2, b to the 3/2. On the next problem, I'm going to rewrite this as being a times 2 over b, and then in the denominator I have 3 over a. Well, when you divide by a fraction, you multiply by the reciprocal, so that should really be a times 2 over b times a over 3. So what we end up getting is a squared, I'm going to put the 2/3 out in front, and the b is in the bottom. So now I have 2/3 as my c value. I have a squared, and I have b to the negative 1st. Part D, it's not my last one of this one. I'm going to factor out the a, so I'm going to take this problem, I'll just work on it right here. I factor out the a, and on the bottom I'm going to factor out the b. And I'm going to end up having just a over b, because the b minus 1's cancel, or a to the 1st power, b to the negative 1st power. A to the negative 1st is okay. B to the negative 1st comes up as b in the numerator, and a to the 1/2 in the denominator, because that is really a to the 1/2 power. That's going to come up to the numerator as a negative 1/2. So remember, when you have the same base, add the exponents. So I'm going to have a to the negative 3/2 b, and that will be my final answer, b to the 1st power, of course. In F, this looks like a doozy. I'm just looking at it, I'm getting a headache. You want to square, so we want to square a to the 2/3, but this is where you have to be careful, because a lot of people want to square those powers and call it 4 over 9, but squaring powers really, I'll rewrite it in terms of what the squaring means. A to the 2/3 times a to the 2/3. In the bottom I have b to the 1/2 times b to the 1/2. So that's basically squaring out what I had before. And then I've multiplied b to the 3/2 over a to the 1/2. So now remember, when you multiply the same base, you add their exponents. So this is going to be a to the 4/3, b to the 3/2. In the bottom I'm going to have b to the 1st power, because a half plus a half is 1, and I have a to the 1/2. So now I've got to bring the a's up to the top, so 4/3 minus a half, and I've got b up in the top, I'm going to have to the 1/2 power. So now I've got to add these fractional exponents. So I've got to work with fractions. I've got 4/3 minus a half, so that's like 4/3 minus 3 over 6. That'll be, oops, this will be 8 over 6 minus 3 over 6, which will give me 5 over 6. So my numerator is going to be a to the 5 over 6 and b to the 1/2. So that'll be my final answer there. Let's see how we're doing on time. And we're 5 minutes into this problem. So now let's move on down to number 4, simplifying logs. So we talked about how to simplify logs in pre-calc, and I'm sure you talked about it in honors. We have to compress the logarithms, and you can only do it if you have the same base. So I notice here I've got all base 2. So what I'm going to do is when you're adding a logarithm, and that turns these two logarithms into multiplication, so I'll say I have log base 2 of 5 times x squared minus 1. And now subtraction means you divide that, so that'll be all over x minus 1. So when I simplify this single logarithm, we have log base 2, I've got 5. Now remember, I can factor this x squared minus 1 into x plus 1, x minus 1, all over x minus 1, and hopefully you see that that cancels with that, and our final answer is log base 2 of 5 times x plus 1. On the next one, I notice that this is log base 4 and this is log base 2. That is not going to work out too well for me. I can't really simplify that. So I think this is as simplified as it can get. Now some people may say, well, I could write it as log base 4 of 9 squared, because that's just bringing the power up to that, the coefficient up to the power spot, minus log base 2 of 3. So now some people would say, well, you have log base 4 of 81. So maybe you could simplify that without a calculator, and some people would say 4 raised to what power gives you 81, and I don't really have an answer for that without a calculator. And so I think right about here is where I'm kind of stuck. I think that might be, if this was textbook math, that might be a misprint. So, you know, but this is probably as far as you can take this problem. On this next one, this is one that we can do. We first take 3. I'm just going to rewrite it because you can take the 2 and put it as a power here. And now a property of logarithms is when you have an exponential raised in its power position, you have the same base logarithm as the exponential. This and this, they wipe each other out and you're just left with x. So using that rule for exponentials, we can just simply say that the 3 and the log base 3 cancel, and you're just left with 25 as your answer, because 5 squared is 25. So that is the end of page 2. I hope you're finding this helpful, and you know, I'll leave these solutions up for you so you can check through them during this first week of school, okay? So I'll post this one, and I'll get working on page 3 as soon as I can. Thank you. Bye.